So what we're talking about today is we're continuing on with similarity. And the first similarity thing that we're going to be doing today is angle-angle similarity theorem. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. And this is really based off of the third angle theorem also, the reason we only need two. Because the third angle theorem stated if two angles in one triangle are congruent to two angles in the other, then the third angles must be congruent also. Because any three angles in a triangle have to add up to be 180. So if two of them already match up, the thirds have to match up as well. Now this is also, we could really call this the angle-angle similarity. There's three angles in one triangle are congruent to three angles in another, then the two triangles are similar. Now, if we remember back to last semester when we talked about congruency, we said angle was not congruent. It doesn't work because we can make the triangle bigger or smaller. So with similarity, it works because we're not having and we're not worried about the shapes being the exact same. They just need to be similar, scaling it up or down. So as long as we have two angles congruent in both of the triangles, then we can say that they are similar. And then we can write our similarity statement. So let's look at the first example. We're given these two triangles here. 1, determine whether the triangles are similar. If they are, write a similarity statement explaining your reasoning. So when we look at these two triangles here, do we know one angle for sure? And what would that be? Angle D and angle G. Angle D is congruent to angle G because they are both what? 90-degree angles. We have our 90-degree angle marker. So C is 26 and H is 64, yes? So they're not the same. Right, we need them to be congruent. .26. So in this triangle here, because we do have a right angle, the other two acute angles have to add together to be 90 degrees. And what we're really doing is we're trying to find out what angle E and angle K are. Now, if we look at angle E, so we can do it by taking 90 and subtracting 26 from it, which would give us 64, which means angle E is 64 degrees. Now, we could have taken 90 plus 26, added those two together, and got 116, and subtracted 116 from 180, which would have also given us 64 degrees, because either one of these works. So it tells us angle E is 64. Do we have two angles that are, another set of angles that are congruent? Well, yes, because angle E is congruent to angle H. Yes? Do I need to find the value of angle K? It will be congruent, yes. But how many angles do I need to be congruent? 2. Because as soon as I've got 2, we're good. So that means that these two are similar. So these two are similar. Now, it did ask us to write a similarity statement. And our similarity statements are going to be the exact same as our congruency statements, and it's been a while since we've done a statement, a congruency statement, or a similarity statement. But when we do either one of these here, it has to follow the same path. It has to follow the same path. CDE. So when I picked the first one, so we said CDE. It doesn't matter which one we pick, what we start and how we follow the path. So since we started off with angle C, we went to D and then E. So we start off with the angle that's 26 degrees, went to the angle that's 90, then went to the other angle. So on the other triangle, I have to follow the same path. They have to match up. KGH. And that's our similarity statement. And we know there's similarity, so these two are similar by what? Angle, angle, similarity. Well, all of these are going to be by angle, angle, similarity if they are similar, yes? Do we know any other ways to show that they're similar? Not too much, I mean, besides all the sides being proportional. But if we want to use this shortcut, we need two angles that are similar, and that's the only shortcut we know thus far. Any questions on this here? All right, let's look at this one here. So we have two angles and two triangles. Do we have two sets of congruent angles in these two triangles yet? No, we only have one. I know that X is congruent to angle R, because they gave us that. I just need another set. Well, I need to either find the value of angle Y or the value of angle S. Which one do we want to find? S. Now, neither one of these angles on this here is 90 degrees, so we can't use the acute angle theorem. But we can still add those two together. We can do 21 plus 61. We can add those two angles together because, again, the sum of any three angles in a triangle is 180. And if I add these together, I get 82. Because we're adding them together to be able to subtract it from 180 to find the missing angle. And if we subtract it from 180, we get 98 degrees. So angle S is 98 degrees. And thus, angle S and angle Z are congruent, and we can say that these two are similar, yes? They're not? Are they going to care about 1 degree? Well, yes. Yeah. So this here is 98 degrees. Well, let's find out what angle Y is, just to make sure. Because if we look at this here, well, 21 plus 99, 0 carry the 1, is going to be 120. And if we subtract 120 from 180, we get 60. So are these two similar? No, because we needed at least two angles. We only have one. So these here are, let's see here, IAR, similar, not similar. Because we don't have two angles that are congruent. We need at least two angles that are congruent to each other. Yes? Any questions on this here? Okay. All right, let's look at these two here. Are these two similar? Okay. So give me two sets of congruent angles. F is congruent to angle R, and this. Okay, those work. I mean, could I have gone this here? Because what are both of these triangles? They are 60, 60, 60, they're going to be equiangular. All three angles are congruent in both, yes? So this is the interesting one because, well, I can say triangle FGH is similar to what? Triangle RQF. It really doesn't matter how we line these up because since all three angles are congruent in both, they're equiangular. It really doesn't matter how I line them up, they're always going to be similar. This is by angle, similarity. Stay. Any questions on any of these here so far? Do you feel comfortable with these here? Yes? Okay. They both have 90, yes? So, can we use just angle F? How many angles do we have at angle F? 2, yes? So anytime we have more than one angle at a point, we have to use 3 letters because we have to do our, so DFE is congruent to BFC. It's almost we trace out the angle with those 3 letters. And the vertex, the point at that angle, is always in the middle. It's always going to be in the middle. Because we have DFE, DFC. Those are both 90 degrees. Now we need to either find CDF or EDF. We need to find one of those two. So for EDF, well, since it is a right triangle, we can use our acute angle theorem in that we can take 58 and subtract it from 90. And 90 minus 58 is 32 degrees. So this angle is 32 degrees. Now, if we wanted to find FDC, we can do the same thing but subtract 32 degrees, and we would get 58. So we can say angle CDF is congruent to angle E, or we could have said that angle EDF is congruent to angle C. We just needed one of those two, because if we have one of those two, we have enough to say that 2 angles are congruent and the figures are similar, yes? Now, it gave us the statements, didn't it? CDF is similar to triangle DEF. By what? Angle similarity. Now, you always want to make sure to double check these when they give you the statements already, that they might line up. Because CDF, 32, 58, 90. The other one, DEF, 32, 58, 90. They are following that same path. Because just because they give you the statements and they are similar, that does work for our statement. We need to be careful because every now and then they love to throw this in. They will give you 2 statements that aren't lined up correctly. So you sometimes have to check and make sure that the lettering is in the correct order. That's it for this one here. Questions? Okay, well, it seems like I'm on the board. Next page. State whether the two triangles are similar. Show that the two triangles are similar. I'm going to go on and say B and C are congruent. We can say that, yes, because they're both the same measure. And really, right, and we're going to use that. It really should be that ABE is congruent to angle ACD, because there are, actually, I was fine with C. Because C only has one angle there, but B has two. But yes, that's what we also want to use. Because I can't say anything about AEB, this angle here, or this angle here, because I don't know if they're parallel. I don't have anything else with that. But what angle do we do know is similar in both? There's something shared. There's something shared in both. It's an angle A in both. So really, angle A is congruent to what? Angle A. Because this triangle here and this triangle here both have angle A. They both have that same angle. It's a part of both of them. So it doesn't matter what the actual measure is, because whatever it is, it will be the same for both, because both of the triangles have that angle, a part of it. Thus, similar by angle. Because these two angles, these two sets of angles are congruent, it means the two triangles are congruent to each other. Questions on this here? Okay. Well, it would be, because that's where we would be going, but we have to use 3 letters because there's 4 angles at V. I think you said UVT. Because what we're looking at is these 2 angles here. Because these 2 angles here are congruent because they are vertical angles. Vertical angles are always congruent. But now we need another set. Right, we do have 2 lines that are parallel, yes? Heads up, heads up. So because of parallel lines, we can say that S is congruent to what? U. Because these are alternate interior angles. So we say angle S is congruent to angle U. Well, we could have also said what? Angle R and are congruent by the exact same thing. Thus, similar by angle. And if you're wondering, yes, those 3 dots mean thus. Any questions on any of this here? All right. this brings us to the last problem that we're going to look at here for today. I know that there's another problem on the next sheet, but these kind of work together. A flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby is 5 foot 4 inches tall, casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? Now, these here are going to be similar figures. And on that next slide, I've already kind of written in the information for us, so we don't have to draw it out. So for y'all, it's on the next page. We already have this written down. Now, the reason that these are similar is twofold. One, we're saying that both of these are right triangles. And that this angle of elevation, the angle that's created from the shadow up to where the top of the pole is and where the shadow ends and the top of her head, are actually going to be congruent because it's at the same time of day. The light that is hitting them to cause the shadow is going to be the same because it's at the same degree. The sun is hitting them at the same spot. Now, 5 foot 4 inches, well, we can't use 5 feet 4 inches if everything else is in feet or if everything else is in inches. We need it in one or the other. I converted everything over to inches because feet, especially with 5 feet 4 inches, well, 4 inches, if I convert it to feet, would be 4 over 12. Well, this is the same as 1/3, which is 0.33. Repeating. It's a non-repeating, non-terminating decimal. So it works a little bit better when we have it at 64 inches instead of 5.3 repeating feet. It works a little bit better. So let's find x. So it's kind of like what we did yesterday. We would have the height of the flagpole over what? The height of the woman, which would be, is equal to what? 600 over 40. We have the height of the flagpole over the height of the woman is equal to the height, the distance of the shadow over the distance of the shadow. Any questions on how we set this up? Okay, what can we do next? We multiply both sides by 64. Now, we don't have to worry about squaring it because since we're not dealing with area, you don't have to worry about squaring. But 64 and 64 will simplify. Because x is equal to 64 times 600 over 40. And if we simplify this here, we would get 960. Okay. And again, so it was asking how tall the flagpole to the nearest inch. Yes? Nearest foot. Okay. Right, to go from inches to feet, we take 960 and divide it by 12, which would be 80 and 1/3 foot, but since it wanted to the nearest foot, it would be a nice round 80. Questions on this? Here. Mm-hmm. Let's see. And that's it. That's the end of lesson 4 2. Thanks.